transferring or propagating the disturbance from one region to another. Sound wave requires a material medium to propagate any sort of disturbance that is set up in a medium. We told as the wave propagates, it carries energy and momentum. Cannot move in vacuum. Why? They require a material medium. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. A new session, a new topic, new thoughts, new ideas. So in this session, I will start with a very, very beautiful topic, something called as waves. Waves, something which is coexisting with us in nature. Dear students, most of the concepts of your 12th standard is associated with the concepts of waves. You study a separate unit itself called wave optics. And anywhere further, understanding of optics becomes very, very important and dependent on the study of waves. So I can say a clinical chapter in your 11th standard, which is the backbone or key to understand concepts next year. What are the thoughts? What is that we study in this chapter called waves? My primary focus will be to understand the meaning of a wave. Then understand classification of waves based on certain parameters. I discuss a very important topic, very, very important topic called progressive wave. We study speed of a transverse wave, speed of a longitudinal wave. We understand Newton Laplace formula for speed of sound in a gas. We study vibrations of air column, open pipe vibrations, closed pipe vibrations. And we understand a beautiful phenomenon called Doppler effect. Therefore, in my today's class, we will have an hawk eye view as to what a wave is, certain terms related to waves, and classification of waves made on analysis with vibrations and medium. Therefore, we will now start understanding the concept of wave. Example 1. I will consider a calm surface of water, pond or lake. I consider a calm surface of water, and I just throw a stone to the calm surface of water. Now, this is the point of impact. There is a calm surface of water. I take a stone, I throw it to the surface of water. This is the point where the stone hits water. Therefore, I told it is a point of impact. Immediately we see circular patterns that is formed around the point of impact. ಯಾವ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಸ್ಟೋನ್ ವಾಟರ್ನ ಸ್ಟ್ರೈಕ್ ಮಾಡುತ್ತೆ, around that point immediately some circular pattern is formed, which means immediately the region around the impact point is getting disturbed. I am consciously using a word called disturbance. So, you have taken a stone, you have thrown it to the calm surface of water. The point where it strikes the surface is called the impact point. Immediately, the neighboring region is disturbed. Circular pattern is formed. Thereafterwards, the next immediate region is disturbed. Again, the next immediate region is disturbed. And as you have studied, this circular pattern is what we call as ripple. And my dear students, understand this disturbance is what we call as a wave. ಕನ್ನಡದಲ್ಲಿ ಇದನ್ನ ತರಂಗ ಅಂತ ಕರಿತೀವಿ. English we have wave, and in Kannada we call it as taranga. So please to understand, the basic definition of a wave is that it is a sort of disturbance that is created in a medium. Any sort of disturbance that is set up in a medium is called as a wave. So the classical understanding of a wave is it is a sort of disturbance. See now, actually when I talk, the region of air molecules near my mouth is disturbed first. That disturbance is carried to the next layer of air molecules. Again, the disturbance is transferred to the next layer of air molecules and finally falls as a sound wave on your ear. So the medium, there is some disturbance created, and that disturbance is what we understand as a wave. Therefore, students, the fundamental definition of a wave, fundamental understanding of a wave says that it is a sort of disturbance in a medium. Now, if you observe the diagram, point of impact, this region is disturbed first, and this disturbance is then carried to the surrounding medium. Again, the disturbance is transferred to the next surrounding medium. The disturbance is transferred to the next surrounding medium. This propagation of the disturbance from one region of space to another is what we call as wave motion. Very important. Wave motion is the transfer of the disturbance from one region of space to another. Disturbance is a wave propagation or carrying that disturbance from one region of space to another is what we call wave motion. So, ಎರಡು important ಪದಗಳನ್ನ ಕಲಿತ್ವಿ ಇಲ್ಲಿ. The first one is wave, which is a disturbance created in a medium. And the second one is wave motion, which means transferring or propagating the disturbance from one region to another. Now, what actually happens during wave motion? So, generally, this is how we represent a wave. Now, we say there are particles in the wave. What happens during wave motion is very important. My dear students, there are 50 students in a class. I take a book, I give it to the first person in the class and ask him to transfer the book to the last person. He need not stand up, go mechanically and transfer the book. He will just pass the book through his neighbors and see that the book reaches the last person. Similarly, when I say wave motion, clearly understand the particles of the medium will not move from one region to another. This particle will not come here. This particle will not come here. this particle will not come here. There is no physical displacement of the particles. Then what happens here? The particles just vibrate about their mean position. They keep on vibrating about their mean position, and it is only energy that is transferred from one region to another. Classical concept of wave motion. During wave motion, the particles of the medium do not physically move from one region to another. There is no physical motion of the particles. Only energy is transferred from one region to another. And therefore we say wave is a carrier of energy. Any wave is a carrier of energy. Why do you call wave as a carrier of energy? During wave motion, the particles of the medium simply vibrate about their mean position, and thereby they are transferring energy from one region to another. Physical motion of the particles is not possible here, and therefore we say a wave is a carrier of energy. When energy is transferred, there is again another physical quantity which is transferred. What is that? Yes, along with energy, momentum is also transferred from one region to another. So we say classically, a wave is a carrier of energy and momentum. So understand, dear students, when we talk about a wave, it is a sort, a type of disturbance that is generated in a medium. The transfer of this disturbance, propagation of this disturbance from one region to another is called wave motion. And during wave motion, energy is transferred from one region to another. Momentum is transferred. So a wave is a carrier of energy and momentum. Now we understand the classification of waves. Probably all these things you should have studied in your lower classes. It is just a recollection of those ideas. Now the classification is done based on two parameters. The first parameter is based on the medium, and the second parameter is based on vibrations. So waves are classified into two types. First, classification based on the medium. Second, classification based on vibrations. And based on the medium, we have two types of waves. When you consider the medium in which a wave propagates. We have two types of waves: mechanical waves, non-mechanical waves. What is a mechanical wave? It is a wave which requires a material medium for its propagation. A mechanical wave explicitly requires material medium to propagate. Without material medium, it is not possible for a mechanical wave to propagate. These waves cannot move in free space, cannot move in vacuum. Why? They require a material medium. See, for example, sound waves. Two people talking to each other on the moon cannot hear. Why? There is no material medium. Sound wave requires a material medium to propagate. It is a mechanical wave. Seismic waves. These are the waves which are generated during earthquakes. They require the surface of the earth to be created. They are mechanical in nature. So, when we talk about mechanical waves, these are the waves which require material medium to move. Without material medium, no propagation. They cannot move in free space, in vacuum. Example, sound waves and seismic waves. When we talk about non-mechanical waves, they are the other type. They do not require any material medium for their propagation. Non-mechanical in nature. They don't require a material medium to move, a material medium to propagate. They can travel in vacuum as well as free space. Example, all electromagnetic waves. Precisely when I say electromagnetic waves, I talk about light. So based on the medium, mechanical waves, they require material medium to propagate. They cannot move in free space. They cannot move in vacuum. Exactly sound waves. Non-mechanical waves, they don't require material medium to propagate. They can move in free space. They can move in vacuum. For example, all electromagnetic waves, especially light. Now, based on vibrations, this you have to understand. We have longitudinal waves and transverse waves. Two types of waves based on vibrations of particles, longitudinal waves and transverse waves. What is the longitudinal wave? Here, the propagation of the disturbance takes place along the direction of wave motion. In whichever direction wave is propagating, for example, if the wave propagates along x-axis, the disturbance of the particles are also in the same direction. So if the propagation of the disturbance happens in the same direction of wave motion. They are called longitudinal waves. They are nothing but mechanical waves, for example, sound waves. Transverse waves, here the disturbance takes place perpendicular to the propagation of waves. So, if the wave is propagating here and the disturbance is perpendicular, symbol for perpendicular, the other way it is T, transverse. Example, light waves. So students, in today's class, we have understood what is a wave, saying that it is a type of disturbance. Wave motion, saying that transference of disturbance from one region to another. We told as the wave propagates, it carries energy and momentum. We studied about mechanical and non-mechanical waves. We studied about longitudinal and transverse waves. Longitudinal waves, the disturbance moves along the wave motion. Transverse waves, disturbance happens perpendicular to wave motion. Longitudinal waves are mechanical waves. Transverse waves, non-mechanical waves. In my next session, I come up with a few more special concepts related to waves. Until then, have a nice time. Thank you.